relative basicities and relative acidities and relative hydrolysis. Relative basicity and acidities will go quickly as a revision because we did them yesterday. Today's topic is actually relative hydrolysis, but I just wanted to review it. Look at this. Before I start this, if I give you a brief description that the basicity depends on what? If this is the ammonia having 3 hydrogens attached, we say it's a base. And why ammonia is a base?
Because of the lone pair of the nitrogen.
Yes, the lone pair electron on the nitrogen. Yes, can accept H positive ion, a proton, by making relative covalent bond. That's why ammonia is a base. So I hope this is the point which is actually we are having. Okay, so ammonia accepts hydrogen ion, right? So nitrogen having a lone pair of electron accepts hydrogen ion. Okay. Now, what we learned, okay, ammonia is not organic compound. When we replace one of the hydrogen, substitute this hydrogen with an organic like alkyl group, like CH3 or anything. So these alkyl groups are what? They are electron donors. They donate their electrons towards nitrogen, resulting increase in the electron density on this nitrogen atom. So I'm going to make these eyes bigger just to explain. So the nitrogen's electron density has increased. When it has increased, it means now it can accept the proton strongly. So it is now more basic or less basic? More basic than ammonia. Okay. So straightforwardly, it is more basic than a pure ammonia, because in ammonia, the electron density on nitrogen was not that strong. You see, this one, small i's, this one is big i's. On the other hand, if you look at this, and I put, for example, phenyl here. Okay, the phenyl, in the case of phenyl, the phenyl is, yes, because this lone pair of electron on the nitrogen is delocalized over the benzene ring. If this alkyl group was EDG, electron donating group, it acts other way around. It acts as electron withdrawing group, acts as. So it pulls the electron density down. So I'm going to reduce the size of the eyes here. So they may look like this. So the electron density on the nitrogen atom is now less than the nitrogen atom on ammonia. If it is less, so it won't accept the proton. It would not be able to accept the proton strongly. So it means it's going to be less basic. So therefore, an electron withdrawing group pulling the electron density away from nitrogen, making it a less basic. An electron donating group pushing the electron density towards nitrogen makes it a more basic. In ammonia, there is no such effect. Then we learned, okay, fine, this is how it is happening in amines. If I put CO with NH2, right? And then, for example, I put this phenyl, or even let's say I put a normal alkyl group. Then what about this?
Again, C.
Yes, now we say that alkyl is far away. CO, yes, it is closer to nitrogen, and because of high electronegativity of this oxygen, it acts as electron withdrawing group. So it pulls all the electron density. In amines, in phenylamine was just passed towards that. That was a mesomeric effect. But in this case, it is gonna pull all the electron density away from nitrogen. So almost letting nitrogen out of electrons. So now it cannot accept even H positive, right? So hence it is the least basic. So amides are very much or least basic than ammonia Why? Because C double bond O. So once you put them in order, you have to put an ammonia and a nitrogen with alkyl group on the top. Then you have to put ammonia, and then you have to put an amine with phenyl group, and then the least basic would be the amides. So amides are the least basic. And on the other hand, if I have, this is a primary amine, that is, if I have secondary amine, like if the nitrogen has two alkyl groups, let's say here is the CH3 and here is the CH3, then what? Yes, is going to be lemma more basic? Because now there are two alkyl groups, so more electron density on the nitrogen atom. So more basic. And what about the tertiary amines? Even more basic. Why the tertiary amine are highly basic, or the more basic? Three alkyl groups attached, so they are the most basic. Is it so? So this is how we look at the basicity and relate it with the electron density of nitrogen atom, accepting the proton strongly or accepting or not being able to accept the proton strongly. Ye to ho gaya how we learn it. Then come to the questions. Okay? If you look at the questions, now if I ask you, bacho, parents, if I ask you to put them in order, please parents. Parents, if I ask you to put them in order, look at this. Ammonia, ethylamine, and phenylamine. Most basic to least basic. Who will be the most basic out of these? Because this is an alkyl group, so it's going to be most basic. So the first of all, C2H5NH2, and then ammonia, and then C6H5NH2. So this is, you put them in order. Here is the most basic, here is the least basic. But once I told you yesterday how you have to explain, you have to compare all three together. No, how do you have to explain it? Once you are writing your explanation, the examiner expects you to write like this. You just have to mention why ethylamine is more basic than ammonia. Okay? Why ethylamine is more basic than ammonia? C2H5 is electron donating group having positive inductive effect. Then
it makes
increasing electron density on nitrogen atom. Or making electrons available on the nitrogen atom. So it can accept proton. So it can accept proton strongly. Proton mean H positive ion, strongly. Then ammonia, okay, where only all hydrogens are attached, no alkyl group, okay, as compared to Bena, where all hydrogens. Okay, now what about the other part? Positive inductive effect. This is a term used to explain that the electron density is passed towards the nitrogen atom. This is known as technically positive inductive effect. Now, what about the rest? Now you have to explain these two. Now forget about the ethylamine. Now just compare phenylamine with ammonia. What do you think? Now you have to tell why phenylamine is less. Yes, so you can say that the lone pair electron of nitrogen, there are two ways to say this, as you are saying, or as I'm going to write it. So I'm going to write both ways. The lone pair electron on nitrogen is passed towards benzene ring in phenylamine, making it less available for protons or H positive ion to accept. Hence, फिर क्या होगा?
Hence, they're less strong.
As compared to ammonia.
जो आपने positive negative वो लिखा है तो वो हम इसमें नहीं डाल सकते.
No, this is mesomeric effect. If you want to write, you can give it. Or you can write in your words. Okay, C6H5 is acting as EWG or electron withdrawing group, making nitrogen electron less available. Okay, so that's why it's weakly. Clear? Okay, next. Now I'm going to ask you, can you tell me इनमें से कौन ज्यादा बेसिक है और कौन कम बेसिक है? Phenylamine and nitrophenylamine. Nitro is EWG. Ayla, can you tell me? Ayla, NO2 is electron withdrawing group. So what do you think, which one is more basic?
It's more basic because it contains.
Nitro is, this is the additional thing which the right one contains, nitro. Nitro is, I'm giving you the information that it's electron withdrawing group. So it's going to pull the electron towards itself. There is no nitro in this side. So when it pulls the electrons of nitrogen towards itself, making it less available, so it should be what? It should be less basic. So nitrophenylamine is less basic than phenylamine. Next, you have to organize these two. These two G. What about this? Done? कौन बताएगा? Reese, can you tell me?
electronegativity of oxygen is more weak than
Why?
the electronegativity of oxygen, right?
आप बताइए, what do you think, Lalma?
Making it less basic than the other one.
C double bond O is electron withdrawing group. It's going to pull the electron towards itself, making.
Less basic.
No, yeah, you can add one more sentence that making the electrons on the nitrogen less available for the proton. Okay, hence less basic. Okay, then ethylamine. Ethylamine goes other way around, where alkyl group pushes the electron towards nitrogen, making it more available for this. Okay, what about these two? Can you arrange them?
So they are already arranged.
No, explanation.
So C4H9 is an electron donating group, creating a positive inductive effect, which makes more proton available for nitrogen. So it is the most basic.
Haris. Sorry. You.
C4H9 means the electron donating group. It makes electrons from protons.
Lalma.
Yes. The alkyl group acts as a neutron donation. The proton is more it's making it more basic.
Is it? What about the phenylamine?
That's as an electron withdrawing group.
Okay. What about these three? Can you arrange these three? These three.
So most basic Q.
Phenylamine, Q, and P.
Most basic Q. Sorry,
Most basic is Q.
least basic is
Phenylamine, I hope you understand. I can draw the structure of phenylamine here. So it is C6H5NH2. Q is here, P is here. What do you think then? Why P is the most basic out of all these? It has an alkyl group that is electron donating group. It's going to push the electron towards nitrogen. So electron density on this NH2, this one where I'm putting a double arrow, a double tick, is the highest. On the other hand, who's next? Who is the least?
Q.
Q is why least? Because when CO attaches NH2, so it's gonna do the real damage to the nitrogen by pulling all its electrons away. Okay?
So what would be the
Phenylamine would be in the center.
so what would be the explanation for it? Like if
No, now as I told you, first you arrange them in order, then explanation comes. Lalma, what is the order then? P is the first, Q is the least, and who is in the middle? Phenylamine. Now, how you put them in order, then you have to explain in pairs. Now, you are not bothering by comparing P and Q. Now, you are bothered by comparing P and phenylamine. So, let's compare P and phenylamine. P is more basic than phenylamine. Why? P has an alkyl group, which is an EDG, electron donating group. The electron density on the nitrogen increases due to the positive inductive effect of the alkyl group. Hence, more electrons are available for the nitrogen to accept. On the other hand, in phenylamine, it goes the other way around. It pulls the electron away from phenylamine, less basic. Then P, the lone pair of electrons. Nitrogen is delocalized over the benzene ring, making it less available. Okay? Got it?
But what would we write if we compare phenylamine and Q? What would be the
Okay, now come to this. Now let's compare phenylamine with Q. Now in Q, you always know what explanation you have to go when you have C double bond O. Yes, so you will say simply that Q has a C double bond O attached with a nitrogen, which is because of high electron density, electronegativity of oxygen acts as electron withdrawing group, making the nitrogen's electron less available. Okay.
but benzene is also a withdrawing group.
Benzene is
Also in withdrawing group.
electron.
Withdrawing.
So could you show us the explanation for a second?
Phenylamine is less basic than B. No, Q has a C double bond O, which is an electron withdrawing. So less nitrogen electrons are able to accept the protons. Now, what are you saying?
I'm saying that benzene attached with phenylamine is also electron withdrawing group.
But as I told you in the previous explanation, there is a way difference. The C double bond O attached with NH2 is a very powerful electron withdrawing because of high electronegativity of oxygen. So phenylamine is just passing the electrons towards itself and then getting it back. It's not just gone. They are just rotating over the wider part of the ring. Okay. Next. Okay, that's Lelma is clear now.
Sorry?
You asked me to explain it again.
It's fine.
Oh, okay. It's done now. Can I scroll down? Okay, now come to the relative acidities. Okay. A quick go through the relative acidities again. Please pay attention. I told you the other day, acidity is actually linked with ionization. Like HCOOH, it ionizes to give what? HCOO negative plus H positive ion. Similarly, CH3COOH ionizes to give what? COO negative plus H plus. Okay. So if you look at this, so in both these cases, what is clear? That OH bond has been broken. This one. This is the bond that is going to break to turn it into ion. Similarly, if you look at CH3, this OH bond is going to break. ऐसे ही है? Is it so? So in both these cases, these bonds are going to break. So acidity entirely depends on this bond. Why? Because when this bond becomes stronger, so less ionization. And less ionization means less acidity. When this bond is weaker, more ionization means more acidity because it's going to give more hydrogen ions, more protons. In this case, now let's compare. There is a hydrogen and there is CH3 here with CO. Now we all know that CH3 is what? Has a positive inductive effect. So it's going to push the electron towards this, making it this bond what? Strong. OH bond is stronger. So when OH bond is stronger, then what? Less ionization. On the other hand, hydrogen is not withdrawing or donating. So that OH bond is not strong enough. Is it so? So therefore, in CH3COOH, the OH bond is stronger than this. When bond is stronger, less ionization. When there is less ionization, mean weakly acidic. So who is less acidic then? CH3COOH as compared to HCOOH. Now in this case, we are going to hit in every explanation the strength of OH bond and linking it with the more or less ionization. Okay? The more ionization mean more strength, more and weak OH bond. Okay, and this strength of the bond, it depends this group that is going to attach with C double bond O on the back side. If it is like this, Cl, CH2, C double bond O, OH. Now in this case, this Cl is actually the electron withdrawing. So it pulls the electrons towards itself. This is called chloroethanoic acid. When the electrons are pulled towards this cell, this OH bond is what? Weak. When OH bond is weak, then ionization is more, unfortunately. I would like to disagree. So weaker bond mean more ionization. This bond is weaker. No, this bond. We are going to talk about this bond only. Now, again, you are distracted. Just stay on this bond only. Just forget about anything else. Okay? So what did we say? The strength of OH bond is going to decide what type of acidity is going to be. Okay? Now, coming back. Look. So, for example, here. Okay, now tell me, which one is more acidic, HCOOH or CH3COOH? HCOOH. Because in CH3COOH, the OH bond is stronger because of positive inductive effect of alkyl group. So methanoic acid is stronger than ethanoic acid. Obviously, we are talking about relative strength. In ethanoic acid, the alkyl group is an electron donating group and it has a positive inductive effect. This increases the electron density on COOH. This results in the increase in bond strength of OH, so less ionization of hydrogen takes place. The 6 to 7. Relative acidities of ethanoic and ethanoic and chloroethanoic acid. What about this? Yeah, ठीक है, रहने दें.
The first
Leave
one
them.
is more acidic, more ionization because CH is an electron withdrawing group. So weak bond of OH. The first one.
What about this? Say it again.
Since Cl is electron withdrawing group, so OH bond will become less strong. So more ionization. Sorry, yeah, more ionization. So stronger acid.
Okay, what about this? Aries, relative acidities of trichloro, dichloro, and chloroethanoic acid. There is a 1 chloro. Chloro is electron withdrawing. There is a 1 chloro, 2 chloro, and here is 3 chloro. What about this? Trichloro is most. Why? There are 3 electron withdrawing group pulling all the electron density towards themselves, making OH bond weakest. Okay. On the other hand, what about dichloro? Less electron withdrawing effect. So OH bond is relatively. Sorry. Again, the same rule. You have to compare first two. Why trichloro is more acidic than dichloro? Got it, huh? And then forget about the tri. Now compare di with chloro. In dichloroethanoic acid, there are 2 electron withdrawing groups. Yeah. Yes, exactly. The first one, that why it is more acidic, and the second one, after the middle one, you have to say why it is less acidic. Okay, now relative acidities of water, phenol, and ethanol. Now look at this. Again, we are not bothered by this. We are just focusing on OH bonds, okay? So just forget about कि ये carboxylic acid है, ये alcohol है, ये क्या है. We are focused on what? OH bond. In water, it is like this. In phenol, it is like this. And ethanol, it is like this. Now, what about this, bacho?
The less strong is CH.
In water, there is no effect. H has no effect on either side. But in C6H5, it is kind of withdraw because there is a mesomeric effect going on. So OH bond is what? Weaker than water OH. So it is more acidic.
Yes.
Weaker bond mean more ionization. What about this? Here it is a positive inductive effect. So what about this? Means?
Less ionization, weak acid.
Yes. So OH bond stronger, so less ionization, so weaker acid than water. Again, Lalma, we have to compare this one with water and then this one with water. Okay? Now, similarly, look at this. If I ask you to put them to compare, look, ethanoic, please pay attention. This is ethanoic acid and this is phenol. Now, please pay attention. Here is the catch. Here is the catch. Look, here is the OH and here is the OH. I just told you a while ago when we were discussing the basicity that this CO group is acting as what? Because it has a power to withdraw सबसे ज़्यादा, बहुत ज़्यादा, too much. Why? Because oxygen की electron density, electron activity ज़्यादा होती है. So इसका मतलब है कि जब CO आके लग जाएगा, as compared to the one there is no CO, तो ये bond क्या हो जाएगा OH का? Weaker. So इसीलिए all the carboxylic acids, they have this thing. They have C double bond O before the OH, right before the OH, right? As compared to the phenol, water, ethanol, where they don't have C double bond O. So C double bond O wala to definitely zyada acidic ho jayega as compared to the phenol, water and alcohol, right? So carboxylic acid are on the top. And ye explanation aap kya doge? कि why ethanoic is why this यहाँ पे explanation अगर आपको देना है कि why ethanol is more acidic, ethanoic acid is more acidic than phenol, because in ethanoic there is a C double bond O which acts as electron withdrawing group and there is no C double bond O in phenol. Now come up with your.
Sir, in ethanoic acid there is the electron.
No, we as I said, we are not bothered by what's behind this. Now we have to just explain C double bond O.
The nearest to OH.
Yes, exactly. Okay, now here it is. So I've just put them together. So सबसे strong acid कौन होते हैं? Mineral. After them carboxylic acids, then phenol, then water, and then who is in the end? Ethanol, right? So this is how the different acidities are still compared. Hydrolysis फिर रह गई आज. But we'll continue with the hydrolysis in the next class. Again, it's the same thing which we are studying here. वहाँ CCl bond को hit करेंगे. Okay. With this, we'll come to end of this first section और फिर हम polymerization करेंगे. If you have any question, please go ahead. Otherwise, that's all from my side.